Welcome to Go Lesson 24. Today we will learn about Goroutines, Go's approach to concurrency. Goroutines are lightweight threads managed by the Go runtime. They allow you to run multiple functions concurrently with minimal overhead. We will cover the Go keyword, multiple Goroutines, anonymous functions, and wait groups. Let us start with basic Goroutines. We create goroutine_basic.go and import FMT and time packages. First, we define a simple sayHello function. Next, a countup function that prints numbers with a delay. In main, we use the Go keyword to start a Goroutine. The Go keyword runs the function concurrently. Main continues immediately. We start another Goroutine for counting. Time.sleep keeps main alive while Goroutines run. Take a moment to review the complete code before we save. Let us review the code with syntax highlighting. Now let us run the program and observe the concurrent execution. Notice how the Goroutine output appears while main continues running. The count numbers print concurrently with main's other work. Now let us run multiple Goroutines at once. We create two functions. Print numbers, takes a label, and count. Each iteration prints and sleeps for 300 milliseconds. Print letters iterates through a slice of letters. In main, we start 3 Goroutines simultaneously. Two call print numbers with different labels, one calls print letters. We wait 3 seconds for all to complete. Review the complete code before saving. Let us review with syntax highlighting. Now watch the concurrent output. See how first, second, and letter outputs interleave randomly. This is because all three Goroutines share CPU time. Anonymous Goroutines define the function inline. We create Goroutine_anonymous.go. A simple anonymous Goroutine uses gofunc followed by parentheses. The empty parentheses at the end call the function immediately. We can pass parameters to anonymous Goroutines. This is important for avoiding closure issues with loop variables. Here we start 5 anonymous Goroutines in a loop. Each receives its own copy of the loop counter. Take a moment to review the complete code. Let us review with syntax highlighting. Watch the output carefully. Goroutines start in unpredictable order, but each finishes based on its sleep time. Goroutine 1 finishes first because it sleeps shortest. Sync.WaitGroup provides proper coordination instead of time.sleep. We create Goroutine_WaitGroup.go and import sync. The worker function takes a WaitGroup pointer. Defer wg.done signals completion when the function exits. In main, we declare a WaitGroup variable. wg.add increments the counter before starting each Goroutine. We pass the WaitGroup pointer to each worker. wg.wait blocks until all Goroutines call done. This is more reliable than using time.sleep. We can also use WaitGroup with anonymous Goroutines. Each task calls deferred wg2.done for proper cleanup. Take a moment to review this complete example. Let us review with syntax highlighting. Watch the output. Workers complete in order of their sleep duration. Worker 1 finishes first, then 2, 3, 4, and finally 5. Let us recap what we learned about Goroutines. The Go keyword starts a function as a concurrent Goroutine. Multiple Goroutines can run simultaneously, sharing CPU time. Anonymous Goroutines are defined in line with Go func. Sync.WaitGroup coordinates Goroutine completion reliably. Thanks for watching Go Lesson 24. In the next lesson, we will learn about channels for Goroutine communication. Subscribe and click the bell to be notified.